Lesson 13-1, Theoretical Probability, and in this lesson you learn to find and interpret theoretical probability of an event, and when are you ever going to use this. Knowing about probability can help you determine the chance of winning a game at a festival. So words that we will learn in this lesson: theoretical probability, outcomes, event, sample space, complementary events. Okay, so let's take a look at this example on a popular television game show. Price is Right. Contestants spin a wheel that is separated into equal sections marked 5 cents, 10 cents, 15 cents, all the way to $1. Okay, so the divisions there are 20 divisions from 5 to $1. Each contestant gets 2 spins. The contestant closest to $1 without going over wins a spot in the showcase. So the question is, what is the theoretical probability or chance that the wheel will land on $1 the first time the contestant spins it? So it's asking what's the probability that it will land the $1 if the contestant spins it one time. So there are 20 equally likely results because 5 cents all the way to $1, intervals of 5 will give you 20 results or outcomes on the wheel. So the outcomes are the number of possible results in an event. Okay, so the specific outcome or type of outcome is called an event. So you have your 20 equally likely results in a particular in this example, and the specific outcome is called an event. So in this case, the event that we want to find is when that wheel will land on $1. Okay, so in this case, the outcomes are all of the different sections that the wheel could stop on, and the event is landing on the dollar. Okay, so the set of all possible outcomes is called the sample space. So basically, all the possible outcomes 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, and 95 and $1 are all part of the sample space, and that's what you have here. The 3 dots indicate the number of the missing numbers, but it's not mentioned in this particular set, but it is included in the set. Okay, so the sample space, okay, for the wheel is 5 cents, 10 cents, 15 cents, all the way to $1. Okay, so we've discussed a few important terms here: theoretical probability, outcomes, event, and sample space. So to find the probability of landing on $1, we can use a ratio, and theoretical probability is basically the theoretical probability of an event is the ratio of the number of ways an event can occur to the number of possible outcomes. Remember, a ratio is, okay, a comparison of two numbers by division, and therefore we have a fraction bar which also indicates division. So in symbols, the probability of an event will be equal to the number of ways an event can occur over the number of possible outcomes. Okay, so in the sample space, there is only one way to land on $1 and 20 possible outcomes. So the probability of landing on $1 will be equal to 1 over 20. Okay, and you can express probability of an event as a fraction, a decimal, or a percent. So the probability that an event will occur, okay, is a number from 0 to 1. So it's only from 0 to 1, not greater than 1 and not less than 0. Okay, so you can interpret probabilities using a number line. If the probability is 0, that means it cannot occur, the event cannot occur. If the probability is around 1/4 or 0.25% or simply 25% here, the event is not too likely to occur. If the probability is equal to 1/2, decimal 0.5 or 50%, it has a 50-50 chance of occurring. If the probability is equal to 3/4, 0.75 or 75%, it is very likely to occur. And if the probability is equal to 1, it's 100% certain that it will occur. Okay? So again, probability of 0 means that the event cannot occur. Probability of 1/2 means that there is a 50-50 chance that event will occur. Probability of 1 means that event is certain to occur. Okay? And lastly, the closer the probability is to 1, the more likely the event is to occur. Okay, so when you talk about probability, we're just talking about numbers between 0 and 1. Okay, let's take a look at example number 1. Example number 1, a set of counters is numbered 1, 2, 3 all the way to 10. Suppose you draw one counter without looking. Find the probability of choosing a number less than 3. Then tell how likely it is to choose a number less than 3. Okay, so if you look at our counters, there are two numbers less than 3, and they are 1 and 2. These ones right here, 1 and 2. Okay, so basically there are two numbers less than 3 and 10 possible, okay, outcomes. So the number of ways, okay, to choose a number less than 3 will be over the number of ways, number of possible outcomes, and that will be 2 over 10. So 2 possible ways that it can occur and 10 possible outcomes. And we always simplify this. 2 over 10 is always simplified as 1/5. So the probability of choosing a number less than 3 will be 2/10 or 1/5. Okay? And since the probability is close to 1/4, it is not very likely to occur. Okay? Let's take a look at example number 2. In example number 2, there are 6 equally likely outcomes on the spinner. Find the probability of spinning a blue. Letter A, and find the probability of spinning a color other than blue. So if you notice, there are 2 blues out of 6 possible outcomes. So it's going to be 2 out of 6. 2 represents the number of ways to spin a blue, and 6 represents the number of possible outcomes. Okay? Therefore, the probability of getting a blue would be 2 over 6 or 1/3. And letter B, find the probability of spinning a color other than blue. So we have 4 other colors other than blue. So it will be 4 out of 6. 4 representing the number of ways to spin a color other than blue, and 6 representing the number of possible outcomes. Therefore, probability of spinning not a blue would be 4 over 6 or 2/3. Okay? So if you look at example number 2 right here, example number 2, basically either one or the other event must take place, but they cannot both happen at the same time. Okay? So in example 2, either you spin a blue or you spin not a blue. So that means they cannot happen at the same time. You cannot spin a blue and not a blue at the same time. It will not make sense. So in this case, notice that the sum of the probabilities of the two events is 1. These events are examples of complementary events. Remember, when you spin a blue, it's 2 out of 6. When you spin not a blue, it's 4 out of 6. And when you add them, they equal to 1. 2 over 6, okay? 2 over 6 plus 4 over 6 is equal to 6 over 6 or 1. Okay? And these are examples of complementary events. Now we define complementary events to be, in words, 2 events in which either one or the other event must take place, but they cannot both happen at the same time. The sum of their probabilities is 1. And in symbols, the probability of event 1 plus the probability of event 2 will be equal to 1. Those are, that's the definition, okay, of complementary events. And let's take a look at example number 3. Okay, let's see how this goes. Let's see how we apply complementary events. And before we do that, the secret word for this particular lesson would be blue devils. The secret word will be blue devils. Okay, so earth science, a meteorologist predicts a 30% chance of rain. What is the probability it will not rain? Okay, so this is an example of complementary event. Okay, the probability of no rain is a complement of the probability of rain. To find the probability of no rain, you can use an equation. Okay, so we say that the probability of rain plus the probability of no rain will be equal to 1, because probability of rain and probability of no rain cannot happen at the same time. So they are complementary events, and we use the formula for complementary events. And we know that the probability of rain is 30%, plus the probability of no rain, which we don't know, is equal to 1. And then we solve a one-step equation. We subtract both sides by 0.3. Okay, so subtracting both sides by 0.3, we now have the probability of no rain will be 1 minus 0.3, or 0.7. Okay, so probability of no rain is 0.7. We convert this into a percent. So the probability of no rain is 0.7, or 70%. Okay, and that's the end of our lesson. Thanks for watching.